his presentation. So Roger is with Water Science Associates, and his presentation's on Lower Charlotte Harbor Flatwoods Hydrological Restoration Project update. This presentation will provide a one-year update on the progress of the Lower Charlotte Harbor Flatwood Hydrological Restoration Project, which relates to the hydrological restoration priority actions of the CCMP. So with that, Roger, the floor is yours.
Okay, well, thank you for allowing me the opportunity to talk with you today and present some of our initial findings that are available at the end of our first year of our project. Next slide. So I'll just quickly go over where the schedule is, and then we'll focus in on what we're going to talk about today. We installed 39 monitoring stations during the period of I guess it was March through May of 2020, and we got everything up online in May of 2020, which was our objective, and we've been collecting data since then. We completed a Task 1 report in June. We did ecological fieldwork in April and May of 2020, and then also in August and September of 2020. Basically, the purpose of that work was to look at vegetation within both Babcock Webb and Yucatans and look for indicators of hydrologic condition. We did it in the dry season, and then we did it in the wet season. And in the wet season, what we were looking at was deviations from what we saw in the dry season. Then we did some flow monitoring. We've been doing that since the summer of 2020. We downloaded data in August, and then in November, well, let's see, yeah, I think November, and then February. And so what we're going to be basically talking about is that work that we've done so far. Upcoming work will be modeling, scenario analysis, and then preparing draft reports. So next slide. So what I'm going to do is I'm going to basically sort of talk through some of our initial findings and compare water level data that we've collected at various locations. The map that's on the right-hand side is showing a portion of Babcock Webb, and the red line across the top is basically State Route 74. And so BW1 is north, northern part of Babcock Webb, and then BW14 on the lower, I guess on the southwest quadrant of the map is the southern portion, but not completely south, but towards the south end of Babcock Webb Wildlife Management Area. And so the water depths are higher at the southern end of Babcock Webb than they are in the northern end of Babcock Webb, and there are reasons for that, which I will talk about in a little bit. Next slide. Again, we're looking at a couple of stations. These are a little bit more in the southern quadrant of Babcock Webb. SP10 is the green line, and that's a station that is just south of Tucker's Grade. You know, there's an exit on I-75 at Tucker's Grade. If you get off and go due east, then you're going to be in the vicinity of where SP10 is. We have another station that's BW19 that's literally on the right-of-way of I-75, where Oil Well Road crosses over I-75. And you see higher water depths at SB10 than you do at BW19. There's some culverts that allow water to flow underneath I-75, and SB10 is located upstream of a woods road. It's called the Sal grade, and there's a weir structure there, and so water levels are, I think, a little higher than normal at BW or at SB10 because of the fact that water is held back to some degree by the Sal grade. It's an old railroad bed, and so the data to me makes sense, and we certainly have adequate hydro period at SP10, maybe a touch high. Next slide. We've now moved to west of US 41. We're in Yucatans Wildlife Management Area. The black line across the top is the county line, county border. So below that black line is Lee County, and the station SP or SR7 that's highlighted in green in the upper right-hand quadrant of the map. That's a power line easement that runs north-south, and along that power line easement, we have a monitoring station there. That's the green line that you can see in the graph. At the south end of the map is the station YP5, and it's highlighted with an orange ellipse, and the orange or gold colored data is shown on the graph. That station is immediately north of Gator Slough, which is a man-made canal system, and there are a number of weir structures on Gator Slough that control water elevations, and those weir elevations are significantly lower than ground elevations in the southern end of Yucatans, and so you can see that at YP5, water rarely gets above land surface, and that's consistent with field observations that we've had in the southern portion of Yucatans. That's significantly drier than normal. Hydro periods at YP5 or at SR7, the green line, those are relatively normal, I would say. Next slide, please. I think we skipped the slide. Did we? Can you go back one? Maybe go back one slide. Darn, there's a slide that I did not, that didn't get included. So I'm going to talk about it because the stations that I'm going to talk about are you can see on this image. Just above the graph, there's a station SR10, also known as YP4, and then there's a station YP6 that is to the west. And YP6 is on the western border of Babcock Webb, or excuse me, Yucatans unit of the wildlife management area. SR10 is pretty much in the middle. Hydro periods in SR10 are pretty similar to what you see at YP at SR7. They're above ground for much of the year. It dries out during the dry season, but there's adequate water at SR10. YP6 to the west is less than 2 miles distance, and water levels are 5 feet below ground there. That's a really dry area of Yucatans. There are ATV trails that allow water to rush off site, and we are seeing evidence of that at multiple locations. North of that, there's a station SR9, and north and west of that is SR8. SR9 is Durden Creek, and SR9 is, or SR8, excuse me, is Yucatans. SR9 is Durden Creek. There are ATV trails, again, allowing water to rush off site quickly in those areas, and those are all areas where we are looking at as potential areas where we would want to put in some low water fords to hold water on Yucatans to improve hydroperids, and the significance of that I will be talking about in a couple of minutes here. So next slide. So I mentioned that we had some ecologists that went out in the field in the dry season of 2020, and then during the wet season of 2020. And the photograph on the left is the southwest portion of Babcock Webb. It's if you are on Oil Well Road driving east across I-75, and you get to the point where Oil Well Road pretty much stops, there is that area is referred to as the South Walk-In area because it's too wet to drive in, and it's too wet because of constraints to flow that are caused by a variety of factors. But that area has much higher water levels, and we believe are higher than normal. And then the photograph on the right is Yucatans, basically at that station that I was just talking about, where water levels are very dry. Water runs off the property very quickly there, and so that's a ATV trail. And if I was to show you a video, you'd see apparent velocity. It's not turbulent flow, but it's it's half a foot per second velocity moving off the property throughout the summer period. So what we have done is we've taken information from these ecological assessments, and we have mapped that information. So let's go to the next slide. We have mapped these locations where we have visited. We've taken that information and we have compared it now to historical aerial photos that Mike Kemmerer and Tim Lieberman georeferenced. Their 1950s vintage aerial photos. And then Kemmerer and Lieberman, Tim Lieberman used to work for South Florida Water Management District and regretfully retired because he's an absolute treasure. Mike Kemmerer is stationed out of Babcock Webb Wildlife Management Area. He used to be the manager of Babcock Webb, and he's taken additional responsibilities on, and the two of them did some really interesting work. So they georeferenced these aerial photographs, and then they took a GIS database called SSurgo, and they laid that soils map on top of the aerial photographs. And then what they did was that soils database was created basically to assist in understanding how soils can be used beneficially. Originally done by the Soil Conservation Service, now NRCS. And so different soil types were ranked in terms of crop suitability. Generally speaking, if it was considered to be suitable for farming and not experiencing a lot of wetness, it was considered as a type of soil that would be suitable for farming. And then there were other types of soil types that were ranked as having poor drainage and being unsuitable for farming. And those areas were ranked as being wet. So what Mike and Tim did was they they did some GIS magic and were able to rank these different crop types or soil types in terms of wet versus dry. And generally speaking, the wet would be considered a mesic flatwood with an optimum wet season water depth of a foot or 0. And then the wet areas would be considered to be cypress or slough or swamp forest, although there's not a lot of swamp forest in Babcock Webb. And then in between you have hydroflatwoods and marsh. So what we did was we then took that hydrologic rank of 1 through 4 and then ranked that as in terms of a depth. Okay. And then we looked at what we observed in the field. And if we were in the field and we observed that the, let's say the high water or the average wet season mark was 1.5 foot above ground surface, and it was a cypress system. And then it happened to be in an area that was ranked as a hydrologic rank of 4, then that would be a area that was essentially similar to historic conditions. However, if we were in the cypress slough and we saw that the water depth based upon vegetation was, let's say, 1/2 foot, then we'd say, oh, well, that cypress system is drier than normal. So let's go to the next slide. And the ranks that we did for water depths, average wet season water depths, are based upon work that Mike Duver has done. Mike, some of you may know, is a noted expert on cypress systems and wetlands of Southwest Florida. He's been managing the Picayune Strand Restoration Project for many, many years. And has done quite a bit of work at Corkscrew Swamp Sanctuary, and he's done work out here in Babcock Webb and Yucatans as well. We had him in the field to help us with some of our work. So now, next slide. So this is the mapped georeferenced aerial photos from the 1950s, and what we did was we used kind of a reverse color scheme that I normally like to use. Typically I like to have the blues for the negatives, but because of the way that we did our hydrologic rank mapping, we kind of flipped the color scheme, and the reds are areas where the observed water depth was less than the optimum water depth. And so anything that's orange or yellow and red, those are areas that so that's where observed depth minus optimum depth. Yes, those are areas that are ranked as drier than normal. The areas that are green are ranked wetter than normal. And we'll go to the next map because it's a little bit easier to see. So let's go to the next slide. So these areas these dots that are green, you can see in the southern portion of the map, there's more green. And you can see on the northern part of the map, there's more oranges. So basically in the southern portion of the map, this area, this is called the South Walton area, that area is wetter than normal. And the areas to the north are a little bit drier than normal. So generally speaking, Babcock Webb, the southern portion of Babcock Webb is quite a bit wetter than normal. That was that photograph that I showed you a few slides back, where there was essentially water everywhere. So that's what we find in Babcock Webb. Next slide, please. This is the same type of information, but this is for Yucatans. Again, we're west of US 41. Burnt Store Road is on the western side. The red line indicates the boundaries of Babcock, or excuse me, of Yucatans. And you can see that this system they're kind of like linear flowways or sloughs. And you see a fair amount of lighter colored vegetation that are either mesic or hydric flatwoods historically. So let's go to the next slide. And so the areas that are drier than normal, again, the same color scheme, are the reds, the oranges, and the yellows. And you can see a fair amount of yellows and reds throughout this area. In Durden Creek, there's a fair amount of areas that are drier than normal. And then in the southern portion of the study area, that you see a lot of areas that are drier than normal. Let's go to the next slide, because I think I've got some zoomed in views. This is Yucatans and Durden Creek, and there's sort of a mixture of conditions, but the closer you get to the western boundaries, the drier typically it is. You see a lot of negative values. That red there, there's red at the western edge of Yucatans Creek. There's red dots at the western edge of Durden Creek at the FWC boundary. I talked about those areas before as having a lot of ATV trails draining water off of that system. Next slide. This is the area north of Zeml Road. Zeml Canal is shown as a linear feature across kind of the northern extent of the property. We have a few areas that are drier than normal. We have a few areas that are a little bit wetter than normal. Generally speaking, this area, the biologists felt were not seriously impacted from a hydrologic perspective. Next slide, please. One of the other things that we did, we had installed some monitoring stations in the South Walton area. We're now looking at the South Walton area again. And when we did the surveying of those monitoring stations that were installed, we noticed that the surveyed ground elevations were lower than elevations that were indicated in LiDAR data. LiDAR is basically what it is a plane flies over and shoots essentially a radar image down, and it bounces off the ground surface or water or whatever, and then they can get an elevation based upon that work. But LiDAR bounces off of water; it doesn't penetrate water. And so we decided that we would look into that. FWC had some money, a little bit of extra money in their budget. So this is a piece of work that was done by FWC, not part of this grant, but we'll be using the data that we've collected as part of this effort to essentially make some corrections to the LiDAR data in this area here. And generally speaking, water levels or ground elevations were lower in many areas than the LiDAR elevations indicated. So this is really good information, and it was an excellent effort on the part of FWC to independently collect this information. And let's see, I think that might be it. What's the next slide? Oh, just some zoomed in views. So there, yeah, generally speaking, the transects there are all showing ground elevations lower, although some areas were okay. So it was a mixture. So that's it, I think. What's the next slide? Oh, yeah. That's our presentation. We are continuing to do monitoring, and that monitoring will go throughout this year, and then we will we'll be moving soon into updating data files for the modeling effort. We'll be calibrating the models based upon the measured data that we've been collecting, and then we'll be using the models to look at a variety of scenarios. At that point, we'll be making recommendations on how to correct hydro periods in both Babcock Webb and Yucatans. And we are also interacting some with FDOT. FDOT is widening Burnt Store Road in Lee County, and they're looking for ways to manage their water from the extra pavement that it's going to be associated with it. And what we would like to do is we'd like to see if potentially FDOT would be interested in funding some hydro period restoration work in Yucatans and Babcock Webb. They have done this in the past. They did it when they widened I-75 from Tucker's Grade down to the Lee-Charlotte County line. And we're hoping that we can work out something similar to that. And that would be a source of funds to implement the recommendations from this study. So we're making sure they're aware of what we're up to, suggesting that there are restoration potential projects that they could fund as part of their work that would ultimately save DOT money, because managing the water within the right of way will be expensive, much more expensive than helping out FWC. So with that, I'll take any questions.
All right, thank you, Roger. Just wanted to remind everyone that this update is we're continuing to try and keep everyone on the TAC updated on this project, the results of which are going to be pulled into the modeling effort, and we will be following up and requesting comments from this committee as the draft report is being developed and near completion. And with that, I see that Mark Walton has a question. So, Mark.
Yeah, thanks, Roger. Bit of a long question, I guess. Given that the hydro periods can vary quite substantially, across neighbouring stations, and that we've got a lot of different stations in that in those areas, and some of them were old stations and some of them were just put in for this project. Can you, I guess, speak to the effort of how you're sort of ensuring that those variations we're seeing across between areas are real, that we're we're verifying sort of information against the field data, or we're ensuring that the stations from various different sources are calibrated together before this goes into modeling, and we get some quite granular patterns in where the water's going and not going.
That's a good question. What we have done when we were doing the ecological field work is we coordinated pretty closely with biologists that work for FWC and really do understand the land. They're doing all sorts of different management activities that get them out of their offices and into the field, which is where those FWC guys and gals like to be. And so they have a feeling of what is typical. And when we did our wet season work, we said, give us a call when you feel that water levels are typical water depths during the wet season. And when you feel they're typical, that's when we'll go out and we'll do our wet season work. And so we've been coordinating pretty closely with them. The other thing they've done is they've done some vegetation analyses separate from this, and they have identified areas that they feel are impacted. And we're going to be coordinating our work with that work that they have done. And then, you know, we're going to be calibrating the model to all these monitoring stations that we have. Some of the stations that we have go back years. There's about, I want to say 15 stations or so that have been operative since 2011. And as the years have progressed, some of those stations were converted from just manual reading water depths at staff gauges to being having data loggers in them. And so we've got some extended time periods of information at some of the stations. And we're going to be looking at as broad a range of hydrologic conditions as we can during the analysis phase. So I think we're going to have a handle on that, but it's something we're very concerned with. One of the things that we may want to do is if we're able to, we'd like to get back out there during the wet season of 2021. The dry season of 21 was kind of weird. It didn't start, we didn't really get a wet season until somewhere in September. And then it was a late wet season. It was like we took the wet season that was typically July through October and shifted it back a couple of months. And the wet season extended into November and to some degree into December. So we'd like to look at these areas again in the 2021 wet season and hopefully get a broader view of hydrologic condition. Did that answer your question?
Yeah, I think it largely touched on. So yeah, really using the the on the ground biological assessments and ecological indicators to verify the measured data, which is sometimes out in the middle of nowhere, just logging itself away and just making sure that it's all lined up.
Yeah.
So yeah, I did have a couple of follow-up questions real quick. One from Lizanne, I'm just passing on as well. How will field drift encountered in collection of groundwater levels be accounted for in the modeling effort?
What we have done is we've had a little bit of drift in some of the meters, and we've solved that problem such that we don't expect it to occur anymore. And what we did is we corrected the data where we felt that there was drift, and I don't think that's going to be a problem for us in utilizing the data.
Thanks. And real quick, and sorry to sort of, I guess, monopolize a bit of the questions here. The point you made about the LiDAR data being above the surveyed ground levels in places. So is that because the LiDAR's hitting the water that's sitting on top of the ground surface?
Yes.
Yeah. Okay. So as we look in the areas that the hydro periods across some of these stations, and looking at ones where water is showing that it's above ground for particular for a certain amount of time in the year, or a certain below ground for below the ground surface, do some of those assumptions need to be checked in areas where you don't have that LiDAR versus survey check?
Well, one of the other things that we did, and I didn't talk about this today because I didn't want to blather on too long, but in 2019, FWC got some mitigation funds from Collier County, or excuse me, Charlotte County, associated with a road widening project. And they utilized that information to convert a number of monitoring stations from manual reads to a data logger, water level data collection. And then as part of that effort also, there were approximately 58 cross sections that were surveyed in Yucatans. And so what we are planning on doing is utilizing that information to have I believe, a more accurate understanding of the flowways in Yucatans. So we're able to take advantage of that information, and we feel like we're gonna be able to have a pretty solid basis to be moving forward with this.
Great. Thanks for answering those questions, Roger. Appreciate it.
Yep. Thank you, Roger, again for that presentation and update on the project. I will ask so that we stay on schedule. If anybody has any additional questions, Roger, would you be able to put your email address on the chat box and
Sure will.